Hi guys, so in this video today what we're going to do is going to look at something that's called Pythagoras' theorem. Now Pythagoras was a mathematician from the Greek era who is credited with Pythagoras' theorem, although it was already known by the Babylonians way before Pythagoras actually was credited with the proof. And he said that if we get a right angle triangle and we label one of the sides x, the other side y, and we label the longest side z, and this longest side is called the hypotenuse. So if we label it x, y, and z, he went and proved that the following relationship holds. He said that x squared plus y squared is equal to the hypotenuse z squared. And that's all it is really, guys. So in order to solve something using Pythagoras, we need to know two of these three unknowns, and then we can rearrange and solve for the unknown that we don't have. So I'm just going to do a couple of examples here. So let's have a look at this triangle here. I'm going to call this one 3, this one 4, and I'm going to try and find the longest side, which is the hypotenuse. I'm going to call that z. So using Pythagoras' formula, it says that the hypotenuse squared, so z squared, is equal to the other two sides squared and summed. So what we have is 3 squared plus 4 squared. We can then work these things out. Z squared, so we're trying to find z. So z squared is equal to 3 squared, and 3 squared is 9, plus 4 squared, and 4 squared is 16. Z squared now is equal to those two numbers added together, which makes 25. 9 plus 16 is 25. And now we have the whole idea that we have the z squared is equal to 25. In order to undo a square, in order to get rid of that square, we need to do the opposite. And the opposite of squaring something is to take the square root. So the next thing we need to do is to square root both sides. And if we do that, the square disappears, and we end up with the square root of 25 on the right-hand side. And the square root of 25 is just 5, because 5 squared is equal to 25. Let's have a look at another example. Suppose in this example what we have is the fact that we know the longest side. So let's say this was 10. And we know that one of the other sides is 6. And I'm going to call this one A. So this time we can see that a squared plus 6 squared is equal to 10 squared. Remember, guys, for Pythagoras, it's this shorter side squared plus this shorter side squared must equal the hypotenuse squared, or the longer side. And also remember, these have to be right-angled triangles. Perhaps I should write that in. So this is obviously a right-angle triangle. Once we've done that, we can't calculate a squared, so a squared stays the same. And the plus 6 squared here now becomes equal to plus 36, because 6 squared is equal to 6 times 6, which is 36, is equal to 10 squared, which is 100. Now, we have this plus 36, which is on the left-hand side, and we have to get all of the numbers over to the right-hand side and leave just the letters on the left-hand side. So I need to do the opposite of adding 36, which is to take away 36 from both sides. If I take away 36 from here, that means I have to take away 36 from the right-hand side. That's our rules of equations. So that now means on the left-hand side, I'm left with just a squared, and that's equal to 100 take away 36. And if we work that out, 100 minus 36 is 64. Now we have a squared is equal to 64, like we did before. What we now need to do is to get rid of that square, which means we have to take the square root of both sides, and a squared square rooted gives us just a, and the square root of 64. And now we put that into a calculator, we can work it out. A is equal to 8. And that's Pythagoras' theorem, guys.